Welcome to Pint of Science 2021 on YouTube. I would like to start proceedings by saying that when Pint of Science holds events at pubs around Australia, we ensure that we recognise the local Aboriginal and Torres Strait Islander nation, one of many that makes up the continent we now call Australia. Now that we're holding the event online and that our speakers and much of our audience are streaming from around Australia, we want to acknowledge all traditional custodians of country, the first innovators and scientists of this land. We pay our respects to Aboriginal and Torres Strait Islander elders past, present and emerging, and recognise their continuing relationship with land, waters and culture. Welcome to Pint of Science. I am David Farmer, former neuroscientist, and I will be your MC for tonight. I have a PhD, so Dr. Farmer is my correct title. It's also a very, very short list of jobs, neither of which are my job. This is Pint of Science. Science is one of the cornerstones of our society, and you may not have realised this, but it comes in pints. Other cornerstones come in different volumes: shots of journalism, decanters of democracy, liters of law, which are measured with painstaking and detestable accuracy. Philosophy is one of the most ancient cornerstones, hence flagons of philosophy. Politics, increasingly, and whatever your allegiance, seems to come in buckets. But science, my friends, science comes in pints. And this is Pint of Science. Welcome. The aim of Pint of Science is to share science in a relaxed environment and give speakers and audience members the opportunity to engage with each other and share their thoughts and questions. And it gives me great pleasure to welcome you to this night, highlighting the M in STEM. STEM stands for Science, Technology, Engineering and Maths. And tonight we venture into the far depths of the acronym towards its very arse end, all the way, in fact, to the M at the end. It stands for maths. And in doing so, for many Australians, also stands for mystifying, monolithic, and even monotonous. This general aversion to maths has led to a decline in maths literacy in Australia, despite a rigorous push in recent years to promote all STEM subjects. Maths has sadly fallen by the wayside to some extent. Luckily, we at Pint of Science are here to ask, why, damn it, why? Tonight we present a fantastic group of panelists for whom M, in addition to maths, stands for majestic, miraculous, and even Moorish. And once they've told us a little bit about who they are and what they do, they'll go on to answer questions like, why does M stand apart from S and TE and STEM? What is maths anxiety and why do people experience it, and can we do anything for them? And finally, of course, where do babies come from? I mean, why do we really need maths anyway? And so you will also be able to ask your own questions through our live streams on Twitter using the hashtag PintAU21 throughout the night. So let's go. Without further ado, here is your first speaker, Dr. Sophie Calabretto, Honorary Senior Lecturer at Macquarie University. Sophie.
Thank you, Dave. That was a beautiful introduction. So yes, I am Dr. Sophie Calabretto. You can just call me Sophie. So I'm an applied mathematician, which means I like using maths to solve real-world problems. And specifically, I'm a fluid mechanist. So I'm interested in the mathematics behind why fluid flows. So when I'm doing research, what I'm really interested in is what makes fluid go from being sort of nicely well behaved and flowing in layers. So we call that laminar flow. So I've got, think fluid in a pipe, just a boring straight pipe, and I've got fluid going through it. What makes fluid go from being laminar to turbulent, right? So think turbulent, like chaotic, messy fluid. Weirdly, this is something that we don't even understand at a fundamental level. And if you think about the world and you think about, so fluid is anything that flows. So liquids are fluids, but so are gases. So air is a fluid, and blood and mucus and all of these different things. And so we have fluids everywhere. We interact with them on a daily basis, but at a fundamental level, we have not literally no idea, but we sort of don't get why they do some of the things they do. So that's what I'm interested in terms of research. And these problems are so complicated that as a mathematician, I often do experiments and also use giant supercomputers to solve these problems, because if I were to sit down with pen and paper, I would just start crying tears of blood very quickly, because we've sort of exhausted all the things that we can do with pen and paper in the problems that I work in. So that's what I do as a mathematical researcher, Dave.
Tears of blood seem like they would present an interesting fluid mechanical problem.
Well, yeah, so I think, like blood is an interesting fluid because you've sort of got, blood isn't just sort of a liquid fluid in itself. There are bits and pieces in blood, so you could think about that as like a multi-phase flow with different things in there. Also, like droplets are quite interesting as well. It's not really my area of expertise, but yeah, fluid is everywhere, anything. So this is Pint of Science. Beer is a fluid. alcohol is a fluid. There's lots of interesting things if you look at fluids, and if you have a glass of wine and you sort of swirl it around and you get those nice little legs on the wine, so the droplets that move down, that's got to do with the viscosity of it, which has to do with the alcoholic content. Like, everything is a fluid, everything is super interesting. But yeah, tears of blood. That would be the next research paper, Dave. So if anyone's watching at home and wants to sort of work on a joint paper about tears of blood, just let me know.
And Sophie, I'm curious, did you always want to be a fluid mechanist, or is this something you happened upon? Which is to say, was your path to being a fluid mechanist laminar or turbulent?
Oh, that's very good. I like to say that I tend to go with the flow a little bit. So,
very nice.
No, I didn't intend to become a mathematician. I didn't intend to become a fluid mechanist either. So I actually went to uni to study physics. So I wanted to become an astrophysicist just because at high school I liked physics and I thought space was cool. And, and at high school you don't really have a great understanding of what real people do in the world. So I went, yeah, astrophysics, great. And I went to uni, and it wasn't until I was doing all the maths that I needed for physics that I realized it wasn't the physics itself that I enjoyed, it was applying maths to real world problems. So I was using maths to solve these physical problems. And so I did sort of, I was going to say like a 180. It's not really, it's, I don't know, sort of like an angle off to the side somewhere. And I ended up doing honors in maths, and that was actually looking at mathematical models of neuron firing. So for me, that was, I was going to say mind blowing. That's not a pun, but it was more about the fact that I could use maths to solve problems in neurophysiology. And I thought that was really, really cool. And the reason I got into fluids was because my honors supervisor was a fluid mechanist, and we got on really well. And he was like, hey, come do a PhD with me, stick around, here are all the interesting problems in fluid mechanics. And then I became a fluid mechanist, and I've sort of never looked back. So it was, yeah, it was an accident. I just didn't make a decision, and this is where I ended up.
Fabulous. And just briefly, if you could, what was the question that you ended up trying to answer when you found yourself in this new field, this field of fluid mechanics?
So as I sort of alluded to before, it was the question was like, why do fluids become turbulent, right? And we were interested in turbulence because, okay, think really good example, an aeroplane. What we don't want is turbulent fluid flow around an aeroplane. So if I've got a plane and I've got a wing, I've got like a nice aerofoil, what I want is for the fluid to come in, I want it to move around the aerofoil, and then I want it to sort of detach off the back in a really nice way. And there are certain ways that we can do those kinds of things, but generally we don't really understand the mechanisms at play. And so often when they design airplanes, they'll design an airplane model, they'll put it in a wind tunnel, they'll look at what happens, they go like, okay, that's great, they'll change it slightly, they'll do that again, and essentially we end up creating things by kind of trial and error, which is not a great way to do things necessarily. So I'm interested in the fluid coming into the wing, what makes it detach off the back in a certain way, what causes it to detach in like a nice laminar way, what causes kind of turbulent eddies and all these other things, how can we control them? So what I do is I take objects, physical 3D objects like spheres and cones, and I put them in a supercomputer and
Oh dear, and we may have lost Sophie. All right, well, Sophie was rounding up there, I'm sure, in a beautiful and lovely way. Is she back?
Hello?
Hello, Sophie, we have you back.
Yeah, I noticed that the screen went black for a really long time, and I didn't know if I should just keep talking. And so apparently, no, I actually disappeared. What was I talking about, Dave?
You were talking about aerofoils and detachment.
Okay, cool. So basically to study those as a mathematician like me, what I would do is I would get a supercomputer and I would get shapes in my supercomputer, so spheres and cones and other 3D shapes. And if I spin those around, what I can do is I can mimic all the things that happen on an aerofoil, but I do that on a shape that is sort of easier to deal with mathematically, basically. And so all of these things, so what I'm looking at is sort of answering questions that are fundamental to fluid physics. So even though I'm an applied mathematician and I want to know how I can use maths to solve real world problems, I sort of taken a little bit of a step back and I want to sort of unlock the secrets of nature, Dave, but only related to turbulent fluid flow.
Is that all? Right, Sophie, thank you so much. That is fascinating. And if you have questions for Sophie, you can start asking them now. Our Twitter hashtag is PintAU21. Please get your questions in. And once we've had a chat to everyone, we will start pitching them questions. I'd like to move on now to Professor Adrian Barnett, Professor of Statistics at Queensland University of Technology, coming to us from his lair, I believe. Professor Barnett.
Yeah, we don't get paid enough to, can't afford
keep the lights on.
Yeah, well, thank you, David. Look, it's really great to be part of this panel. So yeah, I'm a proud and happy statistician. I started life as a statistician in 1994. I got a job with a drug company, and they had a very good antibiotic, but it tended to give people diarrhea. So my first job was trying to helping them make a drug that kept the infection curing properties, but didn't give people the runs. So I quite literally started at the bottom, and my job hasn't changed much since, because my first job is pretty much what I've been doing today, which is trying to use data to work out how to make medicine and hospitals run better. And that might sound a bit boring to do the same thing for the last, how many years? It's 28 years. But, I've looking at climate change, air pollution, schizophrenia, hospital cleaning. That was a really good one. So I've actually had a tremendously rewarding and engaging job all this time. And actually, there aren't enough of us to go around. So every week I will turn down sometimes very large projects because I just cannot take it on. And I also say to them, and by the way, I don't know anybody else who can, because every statistician I know is working at full speed. Something I don't understand, though, because I do understand supply and demand, is why statisticians' wages are not sky high, because they should be. But I think we're maybe a bit too nice, and maybe we got into it for the science rather than the money.
My experience of statisticians is that they are very nice. They are so nice that I married one at one point in my life, and I'm still married. I have a quick question for you. You mentioned that you use statistics in order to improve the properties of a drug. How exactly did your statistical knowledge factor into the drug itself? What part of the process were you taking part in? The designing a molecule, or was it part of the trial, or what was it?
No, it was the trial. Yeah.
Okay.
So they'd put a little bit, I think it was chalk. I might be giving away secrets here. They'll probably still come and chase me after all these years. I think they just put a bit of chalk in the pill, and then they gave the patients this lovely stool diary, which I don't know if you've ever had to complete one of those. So
not.
It had like frequency and softness. There's a stool scale, actually. It's named after Bristol. Bristol in England gets the stool scale. So it was actually very interesting data. We were trying to measure the fairest measure of a foul, was what we used to say. But I actually made quite a lot of mistakes back then.
In what way? Job. Please tell us about the mistakes.
Well, I think, I often think about that first job, and I think I would have done it a lot better because, well, actually one thing that would have been really interesting to do was simply, we had this very fancy scale, right? But people, your own bowel habit, I have to say. So I actually just wish we just asked everybody, and it was a randomized double-blind trial, so we would have got balance. I actually just wish we could have asked one question: did this pill make your poo better or worse? And then we would have got a sort of a cleaner, for want of a better word, measure of what was going on.
That's a very, very poor or good choice of words. I'm not very sure which. Right. Let's move on, shall we? Again, keep those questions coming in. If you have questions about statistics, about poo, about anything at all that you'd like to ask Professor Barnett, please keep them coming in. We turn now to Dr. Saskia Freitag. Dr. Saskia Freitag is a postdoctoral researcher at the University of Western Australia, who also wins the prize for the best Twitter handle of the night for Trashy Stats. At Trashy Stats, give her a follow. Dr. Saskia Freitag, hello and welcome.
Hi. Yeah, that's definitely my greatest achievement. That handle.
I'm sure not. No, tell us about your achievements, please.
So I'm also a statistician, but I have taken a little bit of a different route than Adrian. So I'm a bioinformatician these days. So that means that I have a special focus on genomic data. So genomic data is anything that has to do with what is in your cells. Like it could be just looking at your DNA, the genome or like RNA and how genes are expressed. And yeah, that's what I do. So as a bioinformatician, you get heaps and heaps of data. We have one of the largest data sets in the world, rivaling the astro scientists, which is really exciting. And soon we're going to overtake them, which I'm very, very excited about, because astroscience is not my cup of tea or my pint, really. So yeah, so we get loads of data, and we have to analyze this data in order to make predictions about things like what is causing a particular disease. For me, I am interested in brain diseases because the brain is the most complex organ and it's so fascinating. Like a lot of you as well, because I heard schizophrenia, neuroscience, so everyone is interested in the brain, clearly. So yeah, I try to find out what is causing particular diseases, particular like autism and epilepsies. And I study a really interesting epilepsy called focal cortical dysplasia, where patients suffer from really, really severe epilepsies that can really heavily impact their lives. And they have to get these basically it's caused by a little area in the brain, these epilepsies. And this area gets operated out in order to alleviate those seizures. And I get to study the data that comes from these tissues, the gene expression, which is really fascinating because it's very rare tissue, obviously. And I get to use really, really cool technologies that now can look at all the cells that are in these tissues and all the gene expression in every cell of this tissue, and then try to find which cells are actually the ones that are causing these epilepsies to occur in these children.
Fascinating. So can you tell us, can you give us a little bit more detail, I guess, and at the same time being general, but how do you go from masses of data to a new finding about epilepsy in the brain, if that makes sense, to identifying cells? What's in the middle of those two things, and what do you do day to day to get there?
Okay, well, what's in the middle of this thing is a lot of data cleaning. So, as every statistician would tell you, 80% our job isn't very fabulous. It's just data cleaning, which means you have to get stuff that is really noise and not interesting biological signal sort of separated from your biological signal. And we use really fast, like really cool techniques, statistics techniques that we basically have this luxury of being able to stand on the shoulders of these giants in the field who have, made these cool algorithms that we just get to use and like try to get our data set so it actually tells us biological signal. And then once we get to that where it's like actually cleaned up, then we typically use fairly simple statistical tests. Like people might have heard of a t-test. So basically just comparing two means. That's a lot of the time that's what it is. And then we get to visualize it, which is probably my favorite part. And I feel like a lot of other statisticians' favorite part, where we get to make cool graphs with loads of different colors. We make it like interesting. And then we get our biologists to look at those graphs and hopefully, get back to us with some sort of understanding where they say, oh yeah, this makes sense. This could be because blah, blah, blah. And then I get to be excited because I, contributed.
Beautiful. Beautiful, beautiful, beautiful. And tell us, did you always want to be a bioinformatician? I know it's a very new field. Statistics is a 20th century kind of field, but bioinformatics is very new. How did you end up there? And was it always something you wanted to do?
So it's actually funny because I never intended to even be a statistician. I wanted to be a mathematician because I thought, I want to earn a lot of money and I want to be a financial mathematician. But then I didn't end up getting the most amazing math score in my international baccalaureate. So I ended up only getting a 6 instead of a 7. And the University College London was like, well, nah, math is probably not for you, but we have loads of free spaces in statistics. Do you want to go study statistics? And I had no idea what statistics was, I think, at the time. And I was very lucky to study statistics at a time where the field was taking off, and now it's kind of ubiquitous. And the same thing kind of happened when I got into bioinformatics. I just had a professor tell me about a well-paid position back in Germany in my home country. And I was like, okay, well, it sounds exciting. I like learning about biology, even though I didn't take it in high school. I'm just going to try it. And it worked out. So yeah, for a lot of it is, as Sophie says, going with the flow.
Absolutely. I love the humbleness of you say you didn't do so well, and now you're a measly PhD and a measly researcher at a prestigious institution. So thank you very much. That's beautiful, beautiful stuff. Keep the questions coming in, please. We would love to fire your questions to these people. I'm gonna, before we do that, fire things over to our final panelist tonight, Professor Asha Rao, who is Associate Dean of RMIT University. Welcome, welcome, welcome.
Thank you. Thank you.
Tell us all about yourself.
Okay, so I'm Professor and Associate Dean of Mathematical Sciences, which basically means that I am the head of mathematics at RMIT. What do I do on a daily basis? I teach students. I actually teach them risk management in cybersecurity, which is, I think, as far as you can get from mathematics. Crazy, but it's so important to be able to that's what I realize when I go online. It's all about, one is the mathematics, which keeps us safe, and the other is the risk management, working out whether we should be pressing a link, clicking on a link. And that's all my research as well. It sits in between. It's like almost like a continuum of stuff. I like to do the very mathematical stuff where we look at the coding of signals. So when I'm speaking right now, it's actually being converted into possibly zeros and ones, and it's coming out. And I know sometimes there is this lag, and that lag is mainly because the signal is not being decoded properly. And that's one part of communications technology. And the other side is cybersecurity. And cybersecurity comes in all sorts of shapes and forms. And some of the things that I've been doing more recently is looking at connections. So connections in graphs, but graphs in a different way. So what is the graph? And I look at it, it's, you look at each person is like a dot. And then if, for example, David, so I'm talking to you, so we can make a line, we can connect the two dots, one dot which is me and the other dot which is you. And then we can do it over social media, for example, and we can find out who is connected to who. And I have used that with a PhD student to work to track money laundering. I've used it with another PhD student to track what is the traction that politicians get when they use social media for campaigning. Mm-hmm. And so different ways. I've used it with a third student in architecture to work out how do architects talk to each other? What is the mathematics behind that? And so basically, for me, it is find a situation and apply mathematics. Where can I apply mathematics?
It sounds like what you enjoy is the variety. Is that why you set out to become a mathematician? Is that what you thought you'd be doing as a mathematician? And is that why you studied it?
Funnily enough, so my master's degree, I did my education in India. My master's degree is actually physics, chemistry, and mathematics.
Right.
And yes, and I had always said to my teachers, my lecturers, that I wanted to do a PhD in chemistry, not in mathematics. But then, by the time I got around to doing a master's degree, I had a child. And, chemistry had 6 and 7 hour practicals. Mathematics in India and Bombay, it was pure mathematics. All I needed was a paper, pencil, and my brain. And I could go in at 9 and finish at 3. So I did mathematics.
Beautiful, 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 beautiful. Right, we've got some lovely questions coming in. So I think what I'd like to do now is I'd like to start this discussion about STEM and mathematics in STEM. So if I could just start the conversation off, if I could just get everyone thinking about, do you think that mathematics stands apart from the rest of the STEM, the STEM letters and acronyms? And if so, what does that mean and what's going wrong? Adrian, do you have any thoughts that you'd like to kick us off with?
No, well, if you look at that, it's probably just because it makes a nice acronym. I mean, the S in STEM is doing a lot of heavy lifting. There's a lot of fields in there. We could easily be in there, in my opinion. I mean, when science started, maths was a big part of it, and we've always been a big part of it. But maybe we're M because we're a bit special, because we do need a bit of help to get people into maths. When I did stats at university, I had like the least cool degree of all my friends. Everybody would ask what we were doing, and the conversation would quickly turn away from me. But I do remember a couple of years later meeting one of the cool kids who was working in a shop, whereas I'd started a career. So, yeah, no, I think M&S, maths and science go together really well. And we're showing that every day.
Cool. Would any of the rest of the panel like to jump in on that?
Yeah, I can try to argue it from the other side, maybe.
Please
Give it a
argue by
try.
all means.
So I think as researchers, we are really uniquely positioned to see that like science and math are interconnected, right? And in particular, we can see that a lot of math gets developed in the abstract and is sometimes light years ahead of what science really needs. So that's really interesting. But I think for the general public, like how you approach science and mathematics is very, very different. And I think that's where the S and the M, maybe that sort of differentiation comes from. So with science, I think you start from like observing the real world and then making sort of like abstract predictions or trying to find patterns, right? And with math, it's sort of the other way around, interestingly enough. So with math, you start from the patterns and then maybe it applies to the real world, but maybe not, right? So I think it's sort of two sides of the same coins. And obviously for us, it's very interconnected because we use math every day in order to do science. But I can see why, like, if you were just experience sort of high school math and high school science, this might be not the same for you.
I guess that's true, isn't it? When we talk about high school, we kind of do, maths is quite abstract at high school, and we almost don't get to, with the exception of maybe physics, we don't get to so much science that really requires quite difficult, interesting maths. Do you think that's true?
I mean, it was true for me.
Oh, sorry, Asha, why don't you jump in on that one?
Yeah, it's basically, I agree. The thing with maths, in many ways, for me anyway, it was just interesting in its own right. So that was the wonderful thing. And what I remembered when you talk about the M in STEM is that in Yuval Noah Harari's book, Sapiens, he talks about the timeline, and he starts saying 13 billion years ago, physics and chemistry were created or came into being. You know what it said to me? Mathematics was there beforehand. It was there. It was always there. So what we are trying to do, and as Saskia said, maths is often, especially pure maths. So if you look at the story of Ramanujan and Hardy, they looked at number theory. So number theory it's the theory of numbers. 1, 2, 3, 4, and very, very large numbers. The other end, and Hardy said that he did work in that because it was the most theoretical. It is still the most theoretical branch of mathematics, and it is the most useless, which is what he said. You do it just for and you know what? All of cybersecurity stands on that. He must be spinning in his grave. Cybersecurity is all based on number theory. And that's the amazing thing. So, what they did 100 years before it was actually used, and that is what mathematics is. We have to, for the scientists to be able to use, for ST and E to be able to use mathematics, it needs to be created like 50 years before.
So
because only then.
Speaking of the acronyms, there's an excellent question from the internet here, an anonymous question from the internet, but a good question nonetheless. Why have STEAM and HAS, which is not one that I was familiar with, humanities, arts, social sciences, to develop as acronyms, but is there a point to dividing them up? So even forgetting about splitting an M and STEM, should we be dividing the humanities and the social sciences from art?
The best one I've heard is by somebody on Twitter who came up with the acronym mathematics. It has got everything in it. It has got arts, it's got maths, it's got science, it's got technology, it's got humanities, everything. Everything is in mathematics. Without HAS, that is social sciences, without creative writing, you can't spread your ideas, whether it is mathematics or poetry. You need the writing, and for in many ways, to me, mathematics is a language. It's not so much a science; it's a language. And even about 30 years ago, you didn't get a Bachelor of Science in mathematics; you got a Bachelor of Arts. So it makes complete sense.
Sorry, can I just jump in there? I actually do have a Bachelor of Arts with a major in mathematics. My
That's
Bachelor of
okay.
Science is all physics. So the only reason that I could become a mathematician was because I happened to do a science arts double degree at the same time, and maths is one of my arts majors.
And David, I mean, I like acronyms, and I'd love it if it was science and maths, but I think the acronym S&M has already been taken.
It has indeed. Everybody at home, don't Google that if you're looking for information about science. But by all means, Google it. You might discover something about yourself. But
I'm sure maths could get involved. I'm sure.
I'm sure there's very important, pendulums and the like, very important mathematics to be done there. So I've got a question here from Yudi on YouTube. A lot of people, and I presume this applies to everyone, because everyone's described something quite applied tonight. A lot of people might say that your research doesn't sound like maths. So has anyone ever accused any of you of not being mathematicians, of being scientists?
Yes.
No.
I just show people an equation and then they walk away.
And they're convinced.
I've always had people look at me like I have antennae growing out of my head.
Yeah,
I'm a proud mathematician. Sorry, Sophie.
I was going to say, I often get accused of being a physicist or an engineer, but to me, it's the approach that you use that makes it different. So there are engineers and physicists who work on the same kinds of problems as I do, but I like to, and I'm going to insult a few engineers and physicists right now. The way that we approach it, I think maths, you start from the bare bones. So we take the equations that govern all fluid motion in the universe, and we go from there. And I feel like a lot of the work I've seen done by physicists, they kind of come in at a slightly higher level with a few assumptions, and then engineers come in like slightly higher, maybe. And that's not all encompassing. And I apologize to engineers and physicists out there. But yeah, to me, I'm a fluid mechanist, but I'm an applied mathematician because it's the way I approach the problem.
It's the language, right? So it's the language.
I think.
Okay. Sorry, go ahead, Saskia.
Oh, yeah. Like, as a statistician, I hate being described as a mathematician, I have to say. Because I feel like, I know it's a branch of mathematics for most, but I just feel like we do something so different as statisticians. It's just very, like, the approach is totally different to what
we call at RMIT, it's the mathematical sciences. So it includes operations research and statistics as well.
No, I totally get that. And I had to go through, heaps of proofs especially during my PhD to get to the things that I wanted to do. But I think statistics is a fundamentally different way of thinking about how you approach science than mathematics is. So what Sophie described about assumptions and equations and starting sort of with the bare minimum, yeah, some of that applies. Assumptions are very important in statistics, but the explorative nature of statistics, where you do a lot of plotting, a lot of looking at your data, and the whole data cleaning thing that takes up 80% of your time, that makes it very, very different to what math is. Math would never even bother with that 80%.
I've heard a nice definition. Mathematicians want to know why it rains. Statisticians want to know when it rains.
I'd like to know both, to be honest.
Greedy.
What a cop out.
And what as well.
So how do we, I'm sensing a little bit of rivalry. This is beautiful. A bit of rivalry between the statisticians and the mathematicians. How does everyone feel about this rivalry? Particularly Adrian and Sophie, we haven't heard so much from you do you feel there's a rivalry between the two disciplines? And if so, how do you feel about it?
I mean, I don't think so, just because I see everything on a continuum, right? So I see sort of pure maths, then going through kind of, am I about to disappear again?
No, you're there.
Oh, you're here. We've got you.
Everything freezes for me constantly. So if you can hear me and see me, that's great, because at the moment I'm making a very unfortunate face on my feed. So yeah, basically I see it as pure maths sort of going into sort of partial differential equations, which then sort of slits into like applied maths, and then applied maths sort of turns into like applied probability and other things, and then eventually that turns into statistics. So to me, I just see everything on like one long continuum, and and it's not to say that there aren't things that jump in between either. So I don't know, like. And also as an applied mathematician who used to be in a department that was full of pure mathematicians, like I think there's even a rivalry within maths that I think is very unnecessary as well.
Absolutely.
So, yeah, I don't know. I don't feel it, but maybe you feel it differently, Adrian.
No, I think we're so small. We've got to stick together to defend. Like, I think mathematical sciences is not a bad phrase. And yeah, I mean, during my PhD, I loved going into the tea room and hearing about what other people were doing. I don't have a tea room in my current job, and I think it's a disaster. I think every science building should have a tea room where you get to meet people from other fields.
Yes, because mathematicians are machines which convert coffee into theorems. So without that, how are we going to exist? How do we write those theorems?
So another question here from Rebecca Harding on YouTube. How do we change the public perception of maths? As a statistician, I know how cool and interesting numbers can be. How do we make maths a conversation starter, not a conversation stopper?
We start with the maths in daily life. They say to parents, read to your kids. I say to parents, do maths with your kids. There's maths in every story. There is maths, whether, you go out into the garden, the way the leaves twirl around a stem, that's mathematics. There are patterns that you can see all the time. And that is how you start, And also importantly, the one thing I love about mathematics is that you can make mistakes and you can fix them. So, and when you fix them, the higher you get, I think I've spoken about that, David, already to you. You get a massive high. So learn to make mistakes and fix those mistakes, and encourage your kids to be brave to make those mistakes.
Okay, so it's so for you, it seems like it starts with the beauty of the everyday. How do the rest of the panel feel about that? What are your party story maths references? What do you do when you want people to be excited about what you do? Saskia, you look appalled at this idea.
I don't want that part. I don't want to be at that party, actually. I have to talk about math. But no.
Saskia, I see this as a job, right? And then you go and you're like, oh, I'm a mathematician. Everyone's like, oh my gosh, you must be so smart. Like, tell me. And I was like, let's just talk about, I don't know, I was going to say sport, but I don't know anything about sport either. So something else.
Yeah. No, I think that's really important to bring it back to the daily life. For me, the other thing I think that you can do beyond that is to try to make it pretty, and math has lots of beauty in it that can be put into nice pictures. As a statistician, I love graphs. I love anything that is colorful and can attract my attention. So the more we try of that, I think, the easier it is. Like infographics that have loads of math and statistics in it are great. And I can't think of anything that is better to like take in the public than things like that.
Beautiful. So with regards to that as well, we haven't talked about maths anxiety yet. So maths anxiety, that feeling of, I can't do this, I don't understand this, I'm not programmed for this, that kind of response from people. Why do people experience this, do you think? When does this start, and why does it start, and what can we do about it?
I think we have a really gross elitism that's sort of tied to maths in a way that we see, we've got this genius persona. So, there are some people in the world who are geniuses. I think you'll find that, the number of them, it's not that high. And I think we get this weird idea in our head that to do maths, you have to be super smart and you have to see all these like magical patterns in the universe that just kind of, you absorb via osmosis or whatever. And that's the thing that I always felt coming through. But I genuinely don't, and I've had this conversation with Asher before, I don't believe anyone is intrinsically bad at maths. I believe if there's something you can't do mathematically, it's because it wasn't explained in a way that made sense to you, or you didn't have enough time to look at it or something. And so I think a lot of if I tell someone I'm a mathematician, the things that, the responses are either you must be really, really smart, or I hated maths at school, or, maths is too hard. And so it's these experiences that people are having. But I think also, and I don't want to put it on the parents as well, but there are also Like if your kid comes home and has homework and they need help with it and they say, I've got English homework, can you help me? And they say, yeah, like no worries. And like, oh, I've got maths homework. Oh, it depends what it is. I don't know if I can do that. So I think there's this weird stigma that we attach to it. And I think maths can be like a bit of an elitist thing, but I don't think it should be.
So you think that some of the blame lies with the mathematicians themselves?
I don't think so. I think it is just the general. Yeah, I think it's the general. Like in India, when I did my master's, there was 125 students doing the masters of mathematics, and about 80% were girls. And we just expected that we would be able to do it. It isn't rocket science. It definitely isn't rocket science. So what research shows is that if the teacher in primary school is not is maths anxious, then that passes on to more to the girls than the boys. And strangely enough, I remember speaking to a primary school teacher just before she was going to met her actually in Berlin, and she said, "Oh, I'm going to be teaching maths from next semester, and I am really scared." And I said, "What are you scared about?" And she said, "About making mistakes." And I said, I cannot believe that. That's the whole thing. It's okay. You can make, and I think that is the main fear that people have of making mistakes and feeling that they have to be perfect. And that is not the case. You don't have to be perfect. I make mistakes all the time. And I do it in class. And I just say, yeah, right. It makes you human. That's what humans are. We make mistakes.
So do you think... Oh, go ahead. Sorry.
I think we also learn so much from mistakes, right? That's really important to remember. And I love the saying that we have at software carpentry, which is a bit different to teaching mathematics, but it's also an area where people have lots of anxiety programming, especially people with who've never touched a computer before other than going onto the internet. And basically they say, well, mistakes are the pedagogy, right? That's the thing you want to teach people how to recover from. And I think if we embrace that a little bit more with mathematics, we would actually get somewhere quicker.
Yeah, so we seem to be hitting a common theme, which is the making of mistakes. And it seems like presumably if we were better at making mistakes and learning from those mistakes, we'd be better human beings all around, not just at mathematics. So is there a problem specifically with mathematics? What is it about maths? If it's not that, if it's not that, what is it? Why specifically maths? Why are we so terrified of maths?
I did hear an interesting thing the other day that, we have specialist teachers in music and specialist teachers in language, but there's very few schools that have specialist teachers in maths.
Right.
Because I think these problems do start early. I've got a daughter who's 5 years old, and I go into the class occasionally, and already I hear people saying, oh, it's too hard. I don't do that maths. And you're talking about the most simple maths. So it really is bad. But I am to blame a bit, because I don't want to teach it anymore, because I've had people come up to me in the first lecture and say to my face, before saying hello, I am going to hate this. And then I've had other people tell me, your lectures made me cry.
Oh dear.
And it's just so demotivational.
Sure.
I would do anything but teach maths or stats now after those bad experiences. I don't want to go anywhere near it again.
No, we need you, Adrian.
Yes, I have to say, Adrian, that, in the middle of my, about 10, 15 years ago, it hit me. And then I decided, no, I wasn't going to let that get to me. I was just going to be even more passionate.
I can't. It's worn me down. I know I should.
You can do this. It's not
I wonder whether this happens to other math teachers as well. It is a hard subject to teach well, and that would be very demotivational every day to have people who were constantly whinging and complaining about it. Fair play to those people. I mean, look, we should probably just pay them more. There you go. There's a controversial thing which does have evidence to show that it improves outcomes. So yeah.
But yeah, getting back to getting back to that specialist teacher thing. Like, I have a friend who was trained as a PE teacher and a biology teacher, and she has to teach 3 maths classes at the school that she teaches at because they don't have specialist teachers. So she's like, to the point where she had to put her foot down and say, I'm not going to teach above year 10 because I don't understand this. This is stuff that I've never done. And it's not to say that she's incapable of it. She just she didn't train as a high school maths teacher. She trained as a high school biology teacher with PE. And yet, so imagine, and she's very enthusiastic and she's a great teacher, but imagine that being given to someone who had absolutely no interest in it. And it's not surprising that we have, and then I guess the question becomes, how do you make more people become maths teachers who want to become maths teachers? And then it sort of then turns into this perception of, why do people not like maths? So I feel like we're sort of stuck in a little bit of a loop. So.
Yeah. No, and it's getting worse. And the government, in their wisdom, decided to make maths degrees cheaper this year. Which then the universities just turned around and said, well, we're going to offer less math courses because we're not going to make as much money from it. The lack of mathematical understanding is going that high. Yes. It's impacting policy on mathematics.
We now don't understand that more is more.
Yeah.
All right, that is a very brilliant and lively debate. I'd like to fire a quick question to Sophie from Larissa Fedunik on YouTube, which is, Sophie, what is the weirdest behaving fluid you have ever studied?
Oh, okay. So I feel like most of the fluids that I study are very boring, sort of watery type fluids. The scariest fluid I've worked with was when we were doing some experiments and we had to shine lasers through several layers of perspex. And so which meant that to get the refractive index matching as we moved through these different things, we used a fluid called diethyl phthalate. And it turns out that if you breathe that in too deeply, it destroys your baby making organs in all genders. But one of the most interesting fluids, I think, people have possibly heard of Oobleck and non-Newtonian fluid, but I don't think they realize that there are so many things that are non-Newtonian. So the idea of a non-Newtonian fluid is if you apply some kind of stress to it, it changes state a little bit. So Oobleck is the normal one where you have cornstarch and you mix it with water. And if you put your hand in it and move your hand around, it acts like a fluid. But if you punch it, it acts like a solid. But it turns out, so that's a shear thickening fluid. But then toothpaste, for example, is a shear thinning fluid. So it's also a non-Newtonian fluid. So if you think about, if you have a tube of toothpaste and you take the top off and you hold it by the end of it so it's pointing down, none of your toothpaste runs out, right? But if you squeeze that, the toothpaste starts to flow and it's shear thinning. So you've applied a shear force and it thins the fluid out. So there's lots of cool fluids. I just deal with water, which is sad.
So. You deal with water, but you're a toothpaste enthusiast. I
love
it very
toothpaste
much.
And I love diethyl phthalate if I don't have to breathe it in.
Well, you've also got lovely teeth, so that's worked out very, very well. Girana on YouTube asks, we see a lot of news reports about amazing new discoveries every day. Do you think maths is often overshadowed in the media? Do we need dedicated maths communicators similar to science communicators?
I would say yes. Because often when I do research and I want to share that research, it's basically they don't understand. So what does that mean? So most of the stuff that gets publicized is it's cybersecurity stuff. It's not the maths. It's the cybersecurity. So we should have maths communicators, people who can talk about maths the way they talk about science. Somebody who can.
I think, when we were talking about earlier about getting kids interested in maths, somebody like Adam Spencer, I really like his stuff, but he's a rare breed. We need more these cool, exciting people who can talk about maths. You do see occasionally maths gets in the news. I don't know if you've seen something like, oh, we found the perfect equation for honey, or we found the perfect equation for chocolate, or they're actually marketing things. I got approached by one of them once. Somebody wanted me to come up with an equation for, I can't remember what they were selling now. I think it was the day you're most likely to get married or something. I think it was a dating agency or something. So a lot of those stories, if you look at them, they're actually just promotional material dressed up as a maths story, and the person who's done the maths behind that is taking money for the wrong kind of maths, if you ask me.
I think oh, sorry, no, go Saskia.
I wish that science communicators would point out sort of the math that goes into the discoveries, and I think that's often poorly done or not done at all. And so it would just be nice if, especially in my area, where these days, actually making the sample doesn't take very long. Like they're in the lab 2 days. I'm there analyzing the data for 2 years often. And that doesn't get pointed out at the end of it, that it was actually like us bioinformaticians that got us over the line in the end, really, like, because that's sort of the time difference that we have here between the 2 days and the 2 years.
Yeah, that was just going to be my point, that I think there is maths in all of these science stories. It's just that it's the application. Like there's this cool thing in biology, there's this cool thing in chemistry, and that's the thing that gets reported on, and they forget all of the maths that's actually supporting these conclusions, or the maths that they've used to, you know, whatever. So I think, yeah, I think Saskia is right. If you have someone who can actually point that out, I think that would help a lot.
I've got a question for Saskia here. It's a loaded one. I hope you enjoy it. Saskia, do you wish you had studied math and worked in finance in the end? Or are you happy that you accidentally ended up as a statistician or a bioinformatician, if you want to be more specific?
No, I love what I do. I think I wouldn't have been very happy just earning a heap of money. I mean, I would probably be or like, you know, probably have a house by now, which would be nice. But okay. This way I got to like move all over the world, which I don't think any other job would have facilitated. I lived in I did my PhD in Germany. I got to like move over to Australia, which is super exciting. I have been really, really fortunate to go all over the world to give talks about my research. And, you know, working in finance, I don't think this would have really been possible, or maybe not as likely, really. So that's exciting.
That is buoying to hear. And a question for Asha. Does working in cybersecurity put you off using social media and other online sites?
So how do I put this? I only went on to social media about 2 years ago. And yes, every time I post, I have all sorts of bells and whistles going off in my head about whether I should be doing it. Should I be posting it? So yeah, because I teach risk management, I try and manage the risk. I am very, very particular about what I type. And yeah, so I mainly talk. So if you follow me on Twitter, I mainly talk about mathematics, which is pretty safe.
You're doing some fairly fine calculations every time you hit that little send button.
That's right. Absolutely.
Cool. Question for Adrian. How do you account for people's biologies? This is about your research to begin with. Can you predict if some people will respond to medication better than others? And how do you do that with statistics?
Yeah, there's a whole area now of precision medicine. I'd be a bit wary about it. It's become a bit of a buzzword. Yeah, there definitely are. And yeah, you certainly can do that with numbers if you've got enough. But you need even bigger samples to do that. Working out whether something works or not is one thing. Working out whether something works in some people, especially when that group maybe becomes small, is a whole other thing. But, you know, just today I was hearing some very interesting stuff on the radio in the UK where they're now inviting huge numbers of the public to get involved in COVID vaccinations, and they're going to, you know, randomize the order of these booster vaccines and who gets what. And, you know, that's fascinating. I think if we want to find out the answers to this kind of stuff, we do have to be involved in more trials. And actually, during the pandemic, we came up with, we wanted to randomize people based on their house number. Like these mass randomized trials, like, okay, you guys have to wear masks, you guys don't, or you guys can go out on Mondays, Tuesdays, and Wednesdays, and you guys can go out on other days. But yeah, if especially for rare stuff, if we want to find the answer to these things, then we've all got to contribute data.
There you go, a call to arms to begin to round up the night. So we're running out of time. We've had a very lively debate here. I've really enjoyed it. I've got a final question here from YouTube, which I'll put to each of you, and I hope you'll give me an answer and give us an answer that will improve the future for us. And that is, what would you say to parents who are raising young children to help their children have a positive relationship with maths growing up?
I would say, don't say, I don't like maths. Don't say, I can't do this. It's baby maths they're doing. You can learn it much faster than they can.
What about you, Sophie?
Yeah, I would agree with that. I would say the first thing to do is not recoil when they come at you with maths. Like if it's something that you don't understand, then it can be an adventure in learning together. And you can say, oh, yeah, I must have done this a long time ago. I've forgotten. Let's remember how to do this. And then, yeah, I think that just, you got to put a positive spin on it, because otherwise we're going to have no mathematicians left. And I think the future will be bleak then. So.
And Adrian.
I would say there's a quote from the head of Google that we have worn thin because we've used it so much. And he said back in 2009, the sexiest job of the future is going to be a statistician. Maybe don't change the word sexy if you're talking to your kids. But if you want a really exciting, really rewarding, quite well-paid job in all these new tech industries, then doing a statistics degree is an awesome way to get into that.
So, and Saskia, what do you think?
I think, utilize all the cool new tools that this age has brought us. I think YouTube is probably the way to go, right? We are on YouTube, but it is about finding the application of these problems, of the math that they are learning in the real world. And I think YouTube, there are so many great YouTubers out there who do exactly that. Take simple math sort of problems or like areas of mathematics and then show how they are used in the real world. And you can watch that together and learn from that together. And that's a great opportunity.
Fabulous.
And can I just add one more thing?
Yes.
A report done by the White House during Barack Obama's presidency found that women who worked in STEM careers earned 33% more over their lifetime than women who didn't. So, and you cannot do STEM without mathematics. So
there you go. The M is in STEM and it's there to stay, and you can make more money and improve your relationship with your children. And there's all kinds of reasons to do it. I'd like to thank you all very, very much for being involved in this panel. So we need to start wrapping things up. I would like to thank our speakers tonight. That's Dr. Sophie Calabretto, Professor Adrian Barnett, Dr. Saskia Freitag, and Professor Asha Rao. There is another panel, which you should be aware of, in 1 hour, another Pint of Science panel at 8:30 p.m. AEST. The theme is Can We Cure Cancer, which I don't know, sounds important, and features panelists developing novel cancer therapeutics and preventions in Australia. Grab some food and drinks in the interim, and please do come back. I would like to thank the volunteers that make Pint of Science possible. If you've ever been to a Pint of Science live event, there are lots of people running around in Pint of Science t-shirts like this one. They are the ones who make it all possible, and I would like to thank them, even our small team of Pint panel organizers, for this online event. Now, Pint of Science is supported by volunteers. If you are able, please leave a donation. There will be a QR code that appears on your screen in the next few minutes. It's right here. Please, if you are able, leave us a donation on the Pint of Science website to keep the event running. And I just want to thank again the panelists and you, the audience. And remember that Pint events in any format are all about connecting over conversations. And I hope that's what we've been able to do tonight, talking about the M in STEM. Thank you all very much and have a great night.